Hello everyone and welcome back to this next lecture. So in the past several lectures, we had examined several of the methods within the Access Manager contract. So many of these methods were public methods, which were either fetching the state variables or were changing the state variables as you need to set up your Access Manager contract. Now in this lecture, we are going to get started with the main focus of this Access Manager, and that is how it allows us to schedule and execute operations in a safe manner. So this schedule method, which permits this particular set of operations, is incredibly complicated and has several checks that have been implemented, right? And it's actually quite difficult to describe this purely in a theory lecture, and therefore it is always better to describe this in code. But describing this only in code is going to be very complicated, which is why I wanted to soften the blow with a theory lecture first, just to describe an essence of what goes on in this schedule method. So first and foremost, again, a little bit of a recap. Why do we even need scheduling? So again, here, this Access Manager contract is kind of an entire corporation, and this corporation is going to be controlling multiple contracts for various reasons, right? It could be per project, it could be per different applications, you never know. Now, if there are so many different contracts, and these could be in dozens or even hundreds, depending on the size of the organization, in that case, it is very difficult to keep track of what is going on. And therefore, in that case, the sensible way to go about it is to therefore not allow executions to happen instantaneously, but rather to insist that whoever wants to execute a method on a target contract must first schedule the operation and only execute it after a certain amount of time. So this allows some kind of auditing to ensure that if an operation has been scheduled, what kind of operation is it? Is it something that is expected? Is it something that is legitimate? Or if not, we can always cancel it. It can be cancelled. Either it can be cancelled by the administrators or it can be cancelled by certain other people who have such privileges. So that is essentially what it's about. And therefore, you will see that in the Access Manager contract, we've already seen that there are two different layers of delays. One is the grant delay, that is, when an account is added to a particular role, there is a delay associated with that particular access grant. The access is not immediate, privileges are not immediately available. The account must wait for a certain amount of time before the privileges become active. And also, for each and every account, there is an execution delay. So depending on the nature of the employee, or rather the level of the employee, there is an execution delay which is applied to each and every operation that is scheduled by the account. So this is how we are ensuring that scheduling results in safe operations within the organization. So let's look at how scheduling actually works. Now, scheduling is a low-level operation. Now, what that means is if an account wants to call a method on a contract which is being controlled by Access Manager, you cannot directly call that method, right? The only way to call that method is by taking the target address and by converting the method and all the arguments required by the method into call data. And we've already seen this. This is a process of encoding. All we have to do is take the function selector and concatenate all the arguments after that. And we've already examined this in a previous lecture. So this low-level corporation is going to specify these three methods, two arguments, but is also going to specify when this particular method should be executed, or at least at which time instant after which this method can be executed. So it is a minimum time instant. You have a certain delay after that. Now, once this is done, we are going to call the schedule method with these three arguments. That is 1, the target, 3, the call data, and when it can be executed. Now this when means the minimum time instant. After this, we are going to run several permission checks, and I'll talk about this in the next slide. Eventually what you get from all this is a tuple. All these permission checks will give you a tuple. The first one is Boolean, is permission granted, that is true or false. The second one is the delay, that is there a delay associated, in which case this is a non-zero number, or is there no delay, in which case it is 0, and that is the case only for admin related methods. So that means methods that can be called by admins, and also accounts that have admin privileges. So this is how it works. So first thing we do is we check for the caller. So first is we have to check if who is calling this particular method. If it so happens that the access manager is calling it, or a child contract of the access manager is calling it, then this is immediately rejected. The reason is, if however in an organization, when you create a child contract, if you declare a public method, and this public method is allowed to call the schedule method or to call the execute method, this is a serious access violation possibility. Because now this public method may not have the same amount of checks as schedule or execute. And therefore, if any operation is trying to be scheduled through the access manager or the child contract, it is immediately rejected. If you want to schedule an operation, an external user must call this. That means it has to be an external to this particular access manager contract. Now the second case is that is not the case. It has not been from internal, from access manager or child. It has been called external. Now the question is, it will be asked, who is this person? That means this account, what privileges does this particular account have? What roles is this particular account added to? And also, this operation that is trying to be scheduled, what is the nature of the operation? Which is the target? Which is the method? Who can access those methods? Who can access those targets? All these checks are provided before it is defined what needs to be done. And this is what can be shown here. So here is where the privileges come in. First things first is we check if the target has been locked. As I said, you can lock a target, which is like kind of freezing it. And if that is the case, we are going to see if the caller has admin privileges, because only an admin can schedule operations on a target that has been closed. The next thing we have to check is if the method in a particular target needs a particular role. That means it can only be executed by a particular role, or it needs only admin privileges. And then we have to check if the caller has those particular admin privileges. Again, if not, we will reject this particular scheduling. So this is how you're going to check for several of these conditions. The last we check is if all the privileges are okay. That is, if the caller has the required privileges and the method can be executed by callers having that particular privilege, then in that case we have to check if a delay is associated with such an operation. Now delays can come for two reasons. Delays can come because the account has been added to a role, and that role and the account has an execution delay. So as I already said, in the accounts, in the role structure, for each and every account, we have an access instance. That is the instance of the access structure. And this access structure has a delay, which is the execution delay. So there is an execution delay for each and every account. And not only is there an execution delay for each and every account, there can also be some other delay associated with the target as well. So then we have to see which is greater. Is it the execution delay or is it the operational delay? And here, for instance, you will see that when the schedule method is called, the caller specifies the when method. So this is automatically a delay which the caller itself is specifying. So here we are going to calculate which is the greater delay. Is it the execution delay specified for a particular account, or is it the operation delay which has been specified by the caller itself? This is the delay that is applied to this particular schedule. That is, when you schedule the operation, it says that this delay should be the minimum amount of time that you have to wait before you can execute it. And then finally comes the time when we schedule it. And here we have to now create a hash. This hash is the operation ID. And this operation ID is to identify a particular operation. The way it is done is this. First, we take the address of the caller. That is the account which wants to schedule this operation. The second is we take the address of the target contract. And the third, we take the call data. Now this call data will contain both the function selector as well as all the arguments which are needed by that particular method. All this is going to be taken together, concatenated all together into one huge hexadecimal value and will be passed to the kcat256 function. Now the kcat256 function can take any string. It can even take another hexadecimal value and convert that into a bytes 32 value. And this bytes 32 value is the operation ID. And this is a unique hash because that's what the kcat256 does. It takes any string and converts it into a unique 256-bit or 32-byte value, and this is an irreversible operation. So now we have to see, after when we create this particular hash, we now check if this operation already exists. That is, the exact operation ID has already been scheduled. The reason is, if you are scheduling an operation repeatedly, you must wait before the previous one has been executed. Which means if there is a schedule, then in that case, a new schedule is rejected. The existing schedule has to be executed or has to expire before a new schedule can be created. Right? Or rather before a new operation can be scheduled. So if this is all done, we are now ready, or rather if there is no such duplication, we are now ready for the final scheduling. And that comes here. So first things we have to do is we have to decide when this particular operation can be executed. So at the time of scheduling, we are going to do what is called as a time instant check, and that I have not described here because I will describe it in the code. But at the same time, we are also going to do something, which is we are going to calculate a nonce. Now a nonce is there in blockchain to a great deal. It keeps track of all the operations that a particular user or a particular caller does. Now in this particular case, for every operation ID, we are going to maintain a nonce. The nonce of course starts at 0, but every time we execute an operation, we will increment the number by 1. So this is a way of keeping track how many times a particular operation has been repeatedly executed. So for example, let's say there is an operation that requires a certain amount of funds to be paid to an account. And this is quite possible because you will have to pay vendors regularly, maybe weekly or monthly or even yearly, whichever way. And therefore this amount may also be the same because this could be an agreed amount between the corporation and the vendor. So this means that this operation is going to be repeated over and over again. But even if it is repeated, you would like to keep track of how many times it is being repeated, right? Is it being repeated 5 times, 10 times, so on and so forth. Just to keep an idea of how many times a particular operation occurs over and over again. It helps in final bookkeeping. So this is how the entire scheduling takes place. So which means once a schedule has been done, we are going to store with this operation ID in the state variable schedule. So there is a state variable called schedules, which I will show very soon in the next lecture when we start looking at the code, and that will store an instance of the schedule structure, and that schedule structure saves these particular values. That is, it saves the time instant after which it can be executed and the nonce that is associated with that particular operation ID. So this is the entire flow of how the schedule works, right? So as you can see, it is complicated, and when we start looking at the code, you'll realize how complicated this particular process is. But this is the beauty of the access manager that has been provided by OpenZeppelin. They have actually invested so much thought into deciding how you can schedule operations in a safe manner if you are a corporation that is using blockchain for all your organization purposes. So when we look into this method, you'll realize the sheer power of this particular contract. So if any of this was not clear to you, please post in the Q&A forum and I'll be happy to help you. Otherwise, I will see you in the next lecture where we will get back to examining the code. Thank you so much for listening and see you soon. Goodbye for now.